What is closure set of attributes? There are two things which we discuss for closure properties. After the closure properties, we can discuss number one, the closure set of functional dependencies, and second one is the closure set of attributes. Closure set of functional dependencies and the closure set of attributes. This closure set of functional dependency is different than the closure set of attributes. Both of them are different. So when we discuss the closure set of functional dependencies, that means given some functional dependencies, we are trying to determine that what are the additional functional dependencies which can occur due to these given set of functional dependencies. And when we are studying the closure set of attributes, that means given some set of attributes that can be determined by using a given set of functional dependencies. So we'll try to find the new attributes which can also be defined using those given set of functional dependencies. So let us do one thing here. We'll start with the discussion of closure set of attributes. Then after this closure set of attributes, we'll start what is the closure set of functional dependencies. So right now it is closure set of attributes. Closure set of attributes. Okay, so what is this closure set of attributes? Assuming that there is a relation which is given to us. This is an example relation where the attributes are a comma b comma c, and the given functional dependencies are like this: a determines b and b determines c. Okay, so this is the given set of functional dependencies. Okay, so when we say we want to find the closure set of attributes, we can say the set of all, we want to find the set of all attributes, the set of all attributes that can be determined using the given set X of attributes is called the attribute closure, and it is denoted by X plus a small plus above X. Okay, for example, here in this specific case, if I say what is the closure set of attribute A, that means we are trying to find A plus. That means using this A, what are the attributes which we can determine? Okay, and to find these closure set of attributes, we'll use the already studied properties, which are the closure properties of functional dependencies, or you can say the axioms constraints. Okay, so here you can see A determines B is already given. Therefore, with the help of A, I can determine B, and A determines B, B determines C. Therefore, A can determine C. That is a transitivity property. So we can say A can also determine C. Okay, so this is the closure set of attribute A, and you can see A can determine itself because that is trivial. A can always determine itself. That is trivial. Therefore, if I say what is the closure set of A, then the closure set of A is ABC. If I say what is the closure set of B, so this B attribute can determine itself because that is trivial, and given that B can determine C, therefore B can also determine C. Therefore, B closure is going to determine BC. Okay, now let us assume we are having this example. We are saying we are having a relation R, A, comma B, comma C, comma D, comma E, and F. This is the relation which we have, and these are the functional dependencies which are given. Functional dependencies like this: AB determines C, BC determines AD, D determines E, and CE determines B. These are the functional dependencies are given. Now we want to find what is the closure of AB. That means AB is a functional dependency which is given. Now we are trying to find what is the closure of AB. So you can see, if we'll find AB closure, then you can see with the help of AB, we can determine AB itself. Now from this functional dependency, you can see with help of AB we can determine C, and we know that with the help of this BC with the help of BC we can determine AD. So A is already there, therefore we can determine D. See how I'm writing this one is, we already studied the properties, like we can decompose this one, we can write it as BC determines A as well as BC determines D. And BC determines A, this A is already here, so we don't need this one. So BC determines D, therefore that is why I'm adding D. And with the help of D I can determine E. With the help of C and E, which is already present, I can determine B. Therefore you can say if I take AB closure, that means I can determine A, B, C, D, E and B. And what does it mean? It means with the help of AB we can do AB can determine A, that holds. AB can determine B, that also holds because it is trivial. AB can determine C, that also holds from the above functional dependencies. We can do AB can determine D, that also holds from the above functional dependencies. We can do AB can determine E as well as AB can determine B. Therefore when B is already there, we already included there. So therefore you can see from AB closure means what are the attributes which we can determine with the help of AB, and we are going to write all those attributes here. Okay, now instead of AB, let us try to find what are the different closures we can find. If we do BC closure, then what will happen? With the help of BC I can determine BC itself. Now you can take this example. With the help of BC I can determine A and D. A and D is not here, so I can write AD. With the help of D I can determine E. Now we have C and E. With the help of C I can determine B, but B is already there. You can see these are the functional dependencies. This is the closure of these attributes, right? So you can see in none here as well as here we don't have F as the attribute. That means with the help of these we cannot determine F. Okay, now if I take CE closure, then what are the things we can determine? With the help of C I can determine C itself. With the help of E I can determine E itself. Now with the help of CE I can determine B. Now BC is already there, so with the help of BC I can determine AD, right? And with the help of AD I can determine E, right? So we'll not be able to determine F again, right? So if we take only D closure, with the help of D I can determine D itself and E. I can determine D and E with the help of D. So you can see I cannot determine B here because we have to have C. At least there should be C. If there's C, then only we can use this functional dependency. So we only have D and E. Therefore with the help, if we do D closure, we can only get DE. So let me take some examples of these functional dependencies. Assuming that we have the relation, or you can say assuming that the functional dependencies which are given, they are as like this. AB can determine CD, AF can determine D, DE can determine F, C can determine G, F can determine E, G can determine A. These are the set of functional dependencies which are given over relation, which is R, A, B, C, D, E, F and G. This is the relation which is given. Now we need to find, number 1, what is CF closure, number 2, what is BG closure, number 3, what is AF closure, number 4, what is AB closure. We need to find all these things. Okay, so let us start with the first one. It is CF closure. So you can see here we have C and F. With the help of C I can determine C itself. With the help of F I can determine F itself. Now you check the functional dependencies. With the help of C I can determine G, so we write G here. With the help of F I can determine E, so we'll write E here. Now is there anything which we can determine with any combination of this? You can see with the help of G I can determine A, right? Or is there anything which is made up of a combination of any one of these? In the left hand side you can see here we have AF, A and F both are already here. Therefore with the help of AF I can determine D, and you can see D and E are already here. So with the help of DE I can determine F, but I have F already written. So but we cannot determine B from any one of them. Therefore if I take CF closure, we are going to get this one only, that is A, C, F, G, E, A and D. If I take BG closure, so let us take what is BG closure. So with the help of BG, I can determine, with the help of B, I can determine B itself. With the help of G, I can determine G itself. So let me elaborate it in some good steps. Now we already got BG. Now check in the already given functional dependencies. Is the left hand side of any functional dependency is made up of any combination of B and G? Is there anything which is made up of any combination of B and G? Yes, this functional dependency is made up of only the combination of B and G. Therefore G can determine A, so I can write A. Now again check, is there any left hand side of functional dependency which is made up of any combination of B, G and A? B, G and A. So is there anything which is there? So yes, there's nothing. Okay, so right, so this here they say something, AB can determine CD. So with the help of AB I can determine CD, so I can write C and D here. Okay, therefore I can write B, G, A, C, D, which are determined by this. Okay, because with the help of CD or we get any combination of this, I cannot determine any other functional dependency out of this. Okay, now let us take the next example. If you want to find AF closure, what is AF closure? With the help of A, I can determine A itself. With the help of F, I can determine F itself. Now with the help of AF, I can determine D. With the help of F, I can determine E. See how I'm saying F, because I'm just checking what are the attributes which you already determined. Then with any combination of these attributes, we will try to see what are the other attributes we can determine. So with the help of F, I can determine E. Now after this, check if there's anything which is made up of any combination of these four attributes only. Check this one. So already include this one, already include this one, and other attributes there's no functional dependency whose left hand side is only made up of combination of these. Therefore with the help of, if we take AF closure, that means we can get A, F, D and E. Now if I take AB closure, with the help of A I can determine A only. With the help of B I can determine B only. Now check, is there any left hand side of any functional dependency which is made up of any combination of A and B? You can see in the first functional dependency, with the help of AB I can determine CD. Now is there anything which is made up of any combination of this? You can see here C can determine G, so we can write G. Again G can determine A, but A is already included, right? So and we cannot include anything else, so it is A, B, C, D and G. This is the closure of AB, or you can say this is the AB closure. Okay, so this is representing a closure of a functional dependency. Now let us take next example. So assuming that the following functional dependencies are given: A can determine B, B can determine D, C can determine DE, and CD can determine AB. This is the set of functional dependencies which are already given, and the relation is A, B, C, D and E. Now first of all, let us find what is A closure. Okay, so with the help of A, I can determine A itself. With the help of A, I can determine B. With the help of B, I can determine D. Right? Is there any left hand side which is made up of any combination of A, B and D? No. So this is closed. Okay, then let us find what if I take B closure. What is B closure? With the help of B, I can determine B itself. Now you can see here, with the help of B, I can determine D. Is there any left hand side which is made up of any combination of B and D only? Nothing. We already include this one, so this is B closure. Then what is C closure? Check the left hand side. With the help of C, I can determine D and E, so I am going to write D and E. Right? Is there any left hand side which is made up of any combination of C, D and E? Yes, you can see C, D. So I can determine A and B. Right? So we are going to determine C, D, E, A, B. Now what if I take D closure? Now with the help of D, I can determine D itself, but in the left hand side there is nothing which is made up of only combination of D, so D closure is D itself. What if I take E closure? Then E closure is representing E itself, because in the left hand side none of them is having E. Okay, now what if I take A, B, D closure? A, B, D closure. That means with the help of A, I can determine A. With the help of B, I can determine B. With the help of D, I can determine D. Okay, now is there any left hand side which is made up of any combination of this? Right, you can see A can determine B, already written, B can determine D, already written. Is there any left hand side which is made up of any combination of this? No. So ABD closure is only ABD. Okay, now let us take the next example. If I say I have the following function dependencies like this: AB determines CD, AF determines D, DE determines F. Maybe I have already taken this example. Okay, so let us look at some more questions after this.